Returning to this again, so I was hoping to get this done in one video, but it's obviously going to take more than one. So going on from yesterday, talking about trying to test the latch and the shift clocks being out of sync. And we're going to be using this kind of combination here. So in this case, it's going to be the, I think it was the, oh, I've kind of forgotten. All right. So I'm interested in the case when the shift is high and the latch is low, or in another way of saying it, the shift is high and not the latch is high. I don't know if that's going to help. It will. We're going to wire this up. So I've actually already started doing this video once before, but yet again, the camera ran out of batteries because I keep forgetting to charge it up. And I keep making long videos, so it keeps running out of power. But it's charged up now, and it's all ready to go. And there's tons of space, so we can't go wrong. So over here is my 74HC595, which is what I'm going to use to provide my AND gate, which is what this thing is here. So the AND part. And we've still got a little bit left, a couple of NOT gates or inverters left on our 4049 over here. So we're going to use those. The first thing we have to do is find the picture of the 4049 in this book. That's not the, did I say 4049? No, the 74HC595. So in this case it's just going to say 7408 because they come in non-HC versions. So that's high speed CMOS, I believe. But they all are wired up exactly the same. They just don't all function electrically the same. But it's hard to get anything in the 74,000 series nowadays that are not the HC versions. So you can get LS versions sometimes, and I've got some LS ones. And they're the TTL ones. But at the moment, we're not going to be doing too much with TTL stuff. So, but we are at some point, believe me. This is a little notch at the top of the computer, or the top of the computer, top of the IC. There's a little indentation, which is over here. So I'll bring it up close, just for the fun of it. So there's the IC there, and the little notch is over there. So that tells me that the ground is actually... So I shouldn't use red, should I? We might as well use a little... It's kind of like, well, if I use these ones, that's way too big. I don't have any short blue ones. No, they only seem to come in... Well, I'm going to use the yellow. Alright, so the yellow is going to be the ground. So if this is... What did I just knock on the floor? Something important. And I just knocked the camera. If this is the way the IC is orientated, this is a better way of doing it. Then this is the ground pin, and I'm going to put that to there. I have a very ambitious idea for a project using logic ICs, which is going to come up at some point, and I've got quite a few. And I think that's, I'm going to be doing a lot of this stuff, and I quite like building things on camera. But I think one of them is going to have a lot of repeated sequences and a lot of repeated ICs. In which case I'm going to get someone to come and help me, and we're going to have a double video, a double person video, which I think will make it quite enjoyable. Alright, and so we now need to make an AND gate. So, where's my picture gone? So I don't really care about the output at the moment. Though I'm going to, for one thing we have to do is we're using the ground from over here, but this isn't actually wired up, so we're just going to put a wire across to here. So these are going into the grounds on here. So now there's power going into this IC, but nothing is happening. Why did I just randomly put this thing here? So I'm going to look at my picture, and I'm going to just use the bottom one, this one here, this AND gate. So I'm going to take that one. So this is going to be my output. We don't need to put a big wire for that. We're just going to use... But we don't even need to use any wires. We can just stuff a little... whatchamacallit? LED from my trusty box that came with that. We're going to use a colour that we haven't used too much. No, yellow's not going to show up, is it? I want something that does kind of show up. So we'll just stick with the red one. I don't think I've got any red flashing things yet. And then I'm just going to put that one in that way. We need a resistor, and I want to use. Where's all the cool ones that I had? They're on the floor somewhere. We're going to use a 470 ohm one, because I've got to stop using those 100 ohm ones because they're just not high enough. But I'm not entirely sure it seems to make any difference. Alright, so that's going to go there. So we can kind of test that it works by alright, I'm going to stick one input to high. Actually, I feel like I should put, I don't know if there's any point. Is there any point using a resistor? I don't think there is. Okay, so we're just going to, this is one input, and we're going to have another input over here. So first we're going to test the AND gate, and we're going to put them both to low, and we're going to start it, and you can see that this thing does not come on. And if we put one input to high and one input to low, it's still not going to come on. So sorry, an AND gate is only going to work when both the inputs are high. So we'll move that out of the way. So it should come on. It's going to come on anyhow. There you go, it's come on. Remember what happens when you don't tie any inputs down. And of course, if we were being really good, we would be tying all the other inputs down. Why does this thing not work? It does work. It's quite impressive that the whole thing works with like pretty much no decoupling capacitors. Oh, I do have them on these ones here. I watched an interesting video about decoupling capacitors today, and I've got them wrong, of course, because you're supposed to put them as close as possible to both the ground and the input and the power and the positive high voltage, but VCC. But I haven't done that because I've only got these little tiny ones. So I should do what that Julian person does and use the big green polyester things. But anyway, that's not for this video, and this one doesn't have one. It doesn't really matter. I'm sure it will be fine. If it starts being quirky, it won't. But anyway, it would help if I tied all the inputs on my CMOS chip to a particular position so that they're not changing the output. Because remember, with the CMOS things, they use their power mainly, well, they use up electrical current mainly when they're changing state. I mean, in this case, it's also using it because it's going through an LED. But if you're not going through an LED and it's just connected to another thing, they're essentially not using any electrical current power at all, except when they change state. So if you don't have them tied down, they're actually changing state all the time, and so they're wasting power, and they're also causing fluctuations in the rest of the circuit. But I don't really care at the moment. But I just want to say that. It's going to be like the little warning thing that comes up every time. So we've done that, but we're not going to do this. So the first thing we have to work out is, I've gone off the thing. So these wires are not meant to go here. So the first wire is going to be going into from my clock. So I want to see, this is where I've gone and got confused, because it's been a while since I've done this. So I don't know where everything is going. So if I can try and remember how this worked. So this is the problem. So the input is coming into here, alright, and then it's going out of here and being inverted. So this is my clock over here. So this is the clock that's going to the latch. That's quite cute. If I can actually get it. I think I've run out of holes. I've used up every single hole in that line. So that's quite annoying. That means we're going to have to, because I can't really tap into it. Well, I could tap into it over there. We'll just tap into it over there. Alright, so this is a bit unconventional. And so this is kind of like what you would expect. So it's going to start flashing too, because the clock pulse is going high and then low and then high and then low, and one of the inputs is still tied to high. So when they both go high, then the output is going to be high, and when this one goes low, one's going to be low and one's going to be high, because the other input is always high at the moment. And so you're going to see this flashing red LED. So far, so good. And the only tricky part now, and this is pretty much going to be it, isn't it? But we'll have a look with it on the oscilloscope, is this orange wire. And I don't feel like it should be orange, should it? It should be like a different color so that it's kind of obvious on the camera. So I'm going to change that one to blue. It's still kind of working because it's kind of like stuck in the look, it's kind of cool. It picks everything up. So if I put my finger like on there, it's like, I don't know, magically going through my finger. And if I put my finger on something that's going to ground, is that going to work? There you go, it works. Look at that, that's so cool. So right now my finger is touching, well, it's not working. Well, that's just ruined everything. But anyway, we have to put this somewhere. So this is supposed to be attached to the output that I'm putting into the latch. And so I was going to get out and it's the one piece of paper that I've gone and lost. Oh, just great. Give me a second. Here it is. I have to go back to here because I forgot which pin is the pin that has the latch on it. So in fact I put this IC the opposite way around, but that's the 4049, isn't it? This is the IC that I want, and that's also the opposite way around. So I put that one facing that way, and I put these ones facing that way, just to make everything confusing. So, but looking at this, the latch one is pin number 12, so that's the fourth in from this side. So I don't think this wire is going to make it all the way across. So we'll just stick you there. I should have got out the longer ones. And then we'll put a green one here. So making a real mess today. And so it's that brown wire. I remember this from last time. In fact, we could have just gone to here, couldn't we? Oh, this is getting crazy. Alright, so this is actually the point where it's going in. So this is from my... I have to show it. I have to show it yet again, so that we all know what we're doing. Except I don't know where I put the piece of paper because they're not in any order. And, oh, come on, it's got to be right here somewhere. It's that one with the capacitor on it. It's not... Well, I'm really stretching out this whole video just because I haven't organized my pieces of paper. So just stare for a second. What did I do with it? Well, it's not here, is it? Oh, well, that's awkward. It's not there. It's not anywhere. So, alright. But anyway, there was a little picture, and I don't know where that one went, and it had the capacitor and the resistor being used as kind of like a voltage divider. But anyway, this is the input into the latch right here, this brown wire, and it's coming off here. So I'm going to attach this, and this is the moment of truth. I'm going to attach this blue thing into here, and it's not doing what I wanted it to do. So why would that be the case? Well, that kind of indicates... Oh, I know why. We haven't put it through the inverter yet. Alright, so this has actually got to go into the inverter. See, I've completely forgotten what the picture said. So we were just doing A and B, so we're not going to see any difference. We need to put B through the inverter first. So... this is, we've just determined the output that we care about. So this brown one here is going to go B for brown, that's quite useful. I've got to get out my little book again for the hex inverter. So over here is the inverter, and it is facing this way, so upside down for you. And I want to feed the input, so I'm using this one. But I'm not using this one here that I can tell. Is that right? No, I am using that one. 1, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, Oh no, I'm kind of using it. Alright, well I'm going to use this one here. So this inverter here does not appear to be used. So I'm going to feed that one into this pin. Alright, no, I don't want to do that. That's the output. So that's going to be, that's the output of the inverter. And what I'm going to feed into it, so this is the output of the latch clock, is going to go into this inverter, this one here, and be inverted, and then it's going to go into this is the moment of truth. And it actually works. Oh my goodness, but I don't know if you can actually see this. I'm going to turn the lights out for a second. So there's so many lights, and you can cover those ones up. But you can hopefully see it is in fact flashing, like very briefly. So that's actually what we were looking for. So that is this little bit here. So it's actually flashing during this little period here. So there is in fact a moment when the shift clock is high, but the latch clock is not. And it's a very short pulse, which is encouraging because it means it's not like any other thing. Because this is how long the pulses are. So this is a very small little clock. So it's during that time, the light will come on when the latch clock is low and the shift clock is high, and it will go off when both of them become high. So it's on for a small bit, so I think that's a success, and so we've kind of done it. But let's just very quickly put it on the scope, and the awfully fancy little scope thing, except where is this going to plug into? Well, this is going to be a bit of a mess, isn't it? Where's the ground that we can use? We'll use this thing as the ground. This is miles away on the board. It always feels a bit odd when you're doing that, but alright. Plugging it in. This is the scope thingy, and activating the scope while we're waiting, and we are going to just attach the probe. I'm turning the lights back on, I think, because you can't see what I'm doing. So we're attaching the scope to this, so that should be the best place. Skip that, and what are we going to get? We're not going to get what we wanted. So what did I do wrong? This thing decided to stop working. No, it's not even attached. Okay, well that was fun. It's still not showing up. So this is an anticlimactic end to the whole story when nothing seems to work. So did I plug it into the right one? Input. Everything. I'm going to change this back to 50 milliseconds. Done. Still don't see anything. So hold on, let's just test it. This is kind of working. I did notice that it didn't. The light just went out. So there we go. It's kind of working on that. But when I attach it to here, you don't actually. No, it is still flashing. So I have no idea why it's not showing up. Oh, there's the little tiny one. It must be too small to see. So we'll go down to 20 milliseconds. Done. This is where I need to use a trigger bit. Okay, we are going to have to try with that, aren't we? Done. Positive edge, normal. Is that going to do it? No. Well, how do I get this to work? This is rotten. That's not helpful. What do these things mean? 1 out of 2. Slope. Half. Right. I think it would just show up at some point. Okay, I think the video is getting too... Oh, hold. I put it on hold. Don't put it on hold. Okay. 10 milliseconds. Done. Turn that thing off to auto. What is external? Done. No, well that wasn't helpful. I don't want to do that one. Internal, and I want it done. And I have to press... Oh no, maybe I do. Let's just try it. It's the only option I haven't tried. I'm pretty sure that doesn't make any sense. No. So I'm going to be honest, I have no idea. It is still pulsing. But it's not showing up. Which is rotten. It should show up at some point, right? So it works fine there, but then it's way too big. And you don't see anything there, and I don't know why. It could be because it's not a very good scope. But that's sad. It's not touching any... Oh, there you can kind of see it. There we go. Kind of worked for a little bit. I wish I could get it to actually just... Why does this feature not work? Try to... Nope. It should... No. Wow, look at this. You can go even smaller. Okay. Positive and normal and done. There. Okay, we're kind of getting it. So there is kind of a very, very, very short pulse showing up when it works. So that's what I'm looking for. And if that's 2 microseconds, so the one thing I was going to do is try and work out, since it's been quite hard to get this to work, well, you can kind of work out how long it is there. So if I can hold it, so that's what the pulse looks like, and this is each little square is 0.2 milliseconds. So that's about 0.3 milliseconds, which is adequate, I think, to do the actual latching. So that's enough time for it to shift, and it's enough time, so there's enough delay between the shift and the latch for it to work correctly. So it's a good time, a good rate. But I just wanted to see, given that I think we've got a 104 capacitor, so that's what it's like 10 nanofarads, is that right? I think it's 10 nanofarads. And I think it was a 10,000K resistor. So having done that, it might not be. Seeing if we can come up with some of the estimate for how long the delay should be. And seeing if that matches up with what you see here. But I think that's kind of roughly what I thought it would be. So that's kept me happy. Sorry if I don't know how to use this thing and I don't know what I'm really doing, but I hope that was kind of useful and interesting as a way of trying to work out if something works without the right equipment. And if so, we've actually done it we've actually worked it out without having to actually use the oscilloscope in the first place, because we can kind of see it's flashing. You can even see it when the lights are on. So it is flashing very briefly. So I think that's a successful thing, and that's what we're going to do for today. And when we come back to this the next time, it's going to be about making these buttons a little bit more intuitive. Look at that, it was a double one. That's not so good. Wow, look at this. So strange things are happening. So this is kind of cool. So now it's double pulsing, so this is kind of interesting. It's actually clocking it along in 2 lots, so we've kind of mucked this up. We have to finish this off with how much time? We've got 4 minutes. If I chuck in, is this a problem caused by not putting in a decoupling capacitor? Well, the only problem is I don't know where all the right size capacitors are. I did have a big bag of capacitors, so don't I not have any spare sitting around? Oh, there must be some in here. This is the 22s. What's this thing? No, I think those are all too small. Oh, here we go. Here's a 104. So I haven't got one that I can stretch all the way across the IC. But if I put one across there, it's still doing it. That's not really a very helpful way of fixing things. So this little circuit here has really mucked everything up. So if I just take it out, if I take out the output, so that puts it back into working. But if I put this back in, it does not work anymore. It double pulses. So the interesting thing is it appears to be double pulsing in both situations, because hold on. No, I can't. Oh, I got 3 on. Huh, now it's back to working the way it's supposed to work. So that's annoying, isn't it? Alright, what if I take... Okay, maybe this thing worked. Take it out. No. So this is not a very stable circuit, is it? It's just not a very good way of doing anything here. And then put that back in. Okay, I'm going to turn the whole thing off. Restart it. Hold it down. No, it's working fine now. It's still flashing. But as you can see, it wasn't quite good. So more learning to be had by me as to why that was the case. If you didn't see what happened, it was double clocking it. So when I held the button down, 2 LEDs came on and it would shift 2 LEDs at a time. So somehow the clock into this thing was being registered twice in both the latch and the shifting clock on here. But it's not doing it at the moment, so this circuit is not 100% stable because it's a big mess. So thanks for watching, and like, share and subscribe, and bye.